To the first perfect problem for Math 112. Essentially what's going on here is you're given a whole bunch of logarithmic equations and you're asked to solve for x. And the way we'll do that, since logs are still pretty new to us at this point, is convert them all into exponential equations. So really we'll use this little key right here, that this statement is the exact same as this statement, to rewrite all these guys into a more familiar form. And then when they're in a more familiar form, maybe we can figure out what x is. So to that end, how should I lay this out? A tells me that log base 2 of 8 equals x. So playing the role of the letter C is the variable x, and playing the role of the letter B is the number 2, and playing the role of the letter A is the number 8. So writing that in this form, I could say that 8 is equal to 2 raised up to the x power. And this, we don't have a way to solve for x. In fact, we do. It would be exactly to change it to this form. But in this form, I don't know what log base 2 of 8 is yet at this point in the class. So it's easier for me to change it to this form and not really solve the equation, but just kind of stare at it. 2 raised up to some power equals 8. Well, 2 times 2 times 2 equals 8. So 2 to the third power equals 8. Maybe 8 equals 2 to the third power, so x equals 3. I guess that's one way you could write it. Okay, I guess I can switch colors so that these don't bleed into each other too bad. Part B, similar, except the 8 and the 2 are kind of reversed. So now I got that 2 is equal to 8 to the x power. Well, 2 is equal to the cubed root of 8. And the cubed root of 8 is the same as 8 raised up to the 1/3 power. So in this case, I would say that x is equal to 1/3. A little tricky. C. For part C, I got that the log base 2 of x equals 4. Okay. So again, just kind of following the same format I did. This is saying that 2 to the 4th power is equal to x. 2 to the 4th power is equal to 16, so I guess x is equal to 16. D, moving right along. Log base 3 of 1/27 equals x. Okay, what that is saying, rewriting that using this little key up here, is that 1/27 is equal to 3 raised up to some power. What is that power? Well, 1/27 27 is 3 to the 3rd power. So I can rewrite this as 3 raised up to the 3rd power. But 1 divided by 3 raised up to the 3rd power is the same as 3 to the negative 3rd power. So in this case, playing the role of x is the negative 3. E. Sure gave you a lot of these. E, log base 4 of 4 root 2 equals x. So that's saying 4 square root of 2 is equal to 2 raised up to some power. Well, it might help to rewrite this. 4 is the square root of 16. And the square root of 16 times the square root of 2 is the square root of 32. And 32 is 2 to the 5th power. So what I have on the left side is really 2 to the 5th power raised up to the 1/2 power, which is what my square root represents. So really what I have on this side of the equation is 2 raised up to the 5/2 power. So when you have an exponent raised up to another exponent, you multiply those. So for this one, I would say that x equals 5/2. I better be a little bit more careful with my room because I'm only on F, and I'm almost to the bottom of my page here. F, log base 2 of root 2 over 2 equals x. So I got that the square root of 2 over 2 is equal to 2 raised up to some power. I think the easiest way to see this is I have 2 to the 1/2 divided by 2 to the 1 power in the denominator. And when you have an exponent divided by an exponent and they have the same base, you can subtract the exponents. So 1/2 minus 1 is negative 1/2. So I get that x is equal to negative 1/2. Part G, log base x of 4 is equal to 81. Is that not, that's not what I, well, that's not what I want. I'm going to change that. I'm going to make this problem the log base x of 81 is equal to 4. I'm going to get rid of that. So what I'm going to do here is I'm going to say that I'm going to rewrite this in my other form. I'm going to say x to the 4th power is equal to 81, or I guess to keep things in the right order, I'd say 81 is equal to x to the 4th power. Well, 81 is 3 to the 4th power. Maybe that's not the best way to write it. How about this? Take the 4th root of both sides of the equation. The 4th root of 81 would be what x is equal to. And the 4th root of 81 is just 3. Because 3 times 3 times 3 times 3 is 81. So I get that x is 3. Okay. Moving on. H. Part H, I have the log base x of 4 equals 1/2. What that means is x raised up to the 1/2 power is equal to 4. In other words, I guess I could square both sides of the equation and get 4 squared, which is 16, would be what h is, what x is. What am I up to? Not quite sure where the rest of these are going to go, but I'll figure it out. Log base 5 of x equals 1. What that is saying is that 5 raised up to the 1st power is equal to x. So what's x equal to? Well, I guess x would just be equal to 5. Not the most interesting problem in the world. Okay. E, F, G, H, I. What do I have? J, K, L left. J. Let's sneak it in here. Log base 5 of x squared equals 4. Rewriting that as I've been rewriting them, I would say that x squared is equal to 5 raised up to the 4th power. So some number squared is equal to 5 to the 4th power. X is equal to the square root of 5 to the 4th power. The square root of 5 to the 4th power is 5 to the 2nd power, which is just 25. Trying to color coordinate so that things don't run into each other. K. K says that the log base 5 of 25 equals 5 minus x. Okay, that's a little bit challenging to rewrite in this form, but I can still do it. I can say that 25 is equal to my base 5 raised up to the 5 minus x power. So 25 is 5 squared. So 5 squared is 5 raised up to the 5 minus x power. In other words, 2 is the same as 5 minus x. So if you solve this equation for x, the 5 minus x must be equal to 2, so the 5 squared gives me 25. So what that tells me is x must be equal to 3, because 5 minus 3 is just 2. And finally, Hij,K,L. Part L says this mess. Log base 5 of this polynomial equals 2. So if I'm going to rewrite that, I'm going to say, maybe I need to write that somewhere else, maybe down here. Part L. This polynomial, x squared minus 7x, is it minus 32 plus 37? Must be equal to 5 raised up to the 2nd power. 5 raised up to the 2nd power is 25. So if I subtract 25 from both sides of the equation, I get x squared minus 7x plus 12 is equal to 0, which I can factor as x minus 4 times x minus 3 equals 0. So I can say that either x minus 4 equals 0, in which case x is equal to 4, or x minus 3 equals 0, in which case x is equal to 3. So for this last one, there's actually 2 solutions. x could be equal to either 3 or 4 and make this equation true. And I guess that's all of them. That's the end of this perfect problem. We'll stop this video here.